Hi, welcome to example 3 of the Unit 1 Day 4 notes. Today we're going to be looking at the using the distance formula. We're going to use that for these two coordinates here. So we're going to find the distance between R and the distance between S. To start off, I'm going to say that R is my x sub 1, y sub 1 point. So negative 1 correlates with x sub 1. 1 goes or correlates with y sub 1. And then S is x sub 2 and then y sub 2. So 2 is x sub 2 and then 5 is y sub 2. Plugging this into the distance formula, it's right above. I'm going to get the distance, which is equal to the square root of the value x sub 2, so parentheses, 2 minus x sub 1, so negative 1, quantity squared, plus, and then y sub 2 is 5, minus, in this case minus 1, quantity squared. Simplify everything inside the parentheses first. So we have d equals the square root of, and then this gives me 2 plus 1 squared plus 5 minus 1 squared. Going from here, 2, so I have d equals the square root of 2 plus 1 is 3, so that's 3 squared. 5 minus 1 is 4, so that's 4 squared. Then if I continue on over here, this gives me d equals square root of 9 plus 16. The way that you square a number is you take that number multiplied by itself, and there's a square key in your calculator that you can use. So 9, now I take 9 plus 16. 9 plus 16 is 25. Then I take the square root. To take the square root in your calculator, depending on the calculator that you have, you will want to do the square root key first, and then 25, and then close parentheses before you push enter or equals. And that gives you 5. The square root of 25 is 5. The next example, part B, again I'm going to notate, I'm actually going to switch to a different color pen just so you can kind of see the difference between the two. Again, x sub 1 and y sub 1, x sub 2 and y sub 2. So what I have is d equals square root of x sub 2 is 8 minus x sub 1, which is 0, squared, plus, now y sub 2 is 0 minus y sub 1 is 6, quantity squared. Looks like we're going to have some problems because we have some negative numbers, but when we square a negative number, it becomes positive. Make sure, as you note that I'm doing this, when I write this out, you notice that I'm keeping the parentheses until after I square, so make sure that you do that as well, especially when you type this in your calculator. Because for this part here, 0 minus 6 is negative 6, but when you type it in the calculator with parentheses like that, a negative times a negative becomes a positive number. So we end with square root of 64 plus 36. Now we need to add together 64 and 36. So that gives us d equals the square root of 100. And we can take the square root of 100 in our calculator, or if you know the two numbers that, or the number that multiplied by itself gives you 100, and that is 10. So this would be the distance between these 2 points is 10 units. Down here below, we're talking about a distance formula hack. This is really thinking about it geometrically instead of algebraically. If you graph the points on a coordinate plane, you can make the segment the hypotenuse of a right triangle. And then you can use the Pythagorean theorem. So just as a reminder what the Pythagorean theorem is, you picked that up in middle school, but the Pythagorean theorem is c squared equals a squared plus b squared. C in this case is the length of the hypotenuse, and a and b are the length of each of the sides. So this is the hypotenuse, which in a right triangle is always the longest side. And then we call a and b, we call them the legs of a right triangle. So C is the hypotenuse, and then A and B are the legs. I will get into example 4 using the distance formula, and I'm going to show you using it geometrically instead. See you in the next video.